In this video, we're going to look at sample space, probability, and two-way table examples. So the first probability game that we are going to be looking at is if I were to flip two coins. So we know that coins have heads or tails. But for simplicity, I'm going to call heads H and tails T. It usually makes it easier to kind of find like an abbreviation, especially when we're looking at making a sample space or making probability area model. So notice that I already went ahead and labeled the top coin 2 and the side coin 1. So I have heads and tails as my options for both of these. That means if I flip one coin and I get heads, and the second coin I get heads, then my option for one of these is heads, heads. The next one would be heads, tails. This one would be tails, heads. And the last one would be tails, tails. So this is fairly similar in terms of the way we are looking at it when we're talking about area models that we've used previously. So now we're going to look at the probability area model specifically. So when we're thinking about coins, we have two options, heads or tails. So the probability of flipping a head is 1 out of 2 because there is one outcome out of 2 that we are looking at. So above here, I'm going to write heads, tails again. But this time I'm going to write their probability next to it. So I have a 1 out of 2 probability of getting heads. I have 1 out of 2 probability of getting tails, and this applies to both coins. Now, to fill out the probability area model, I'm going to do something very similar to what we have done previously using area models, which is multiply. So I'm going to multiply the 1/2 probability times the 1/2 probability, and I get 1/4. Now I'm going to do that for each of these. So I have 1/2 times 1/2, which is also 1/4. 1/2 times 1/2, which is 1/4. And 1/2 times 1/2, which is 1/4. Notice that all of these are 1/4 because they have equal probability. Also notice that if I add up all my 1/4, I end up getting 4/4, which is 100%. This is 100%. So my area model for probability should always give me 100% when I add up everything inside. So how do I use this? So what if I want to know the probability of flipping one head and one tail? Well, I'm just going to go over here and check. So the probability of flipping a head and a tail, I have 2 of those, right? So this is tails, heads. This is heads, tails. So I actually have 2 possibilities right here that could happen. So I need to look at tails, heads plus heads, tails. So if I go to my area model, I'm looking at 1/4 and 1/4, which means that I have 1/4 plus 1/4, which is 2/4. So my probability of flipping one head and one tail, we're not talking about order, we're not worried about order, is 2/4, which is the same thing as 1/2. So that's my probability if I were to flip 2 coins and get a result of 1 heads and 1 tails, doesn't matter what order. In the next example, we're going to look at a different kind of setup for events. So if you're given a spinner with 3 colors, purple, blue, and white, and a bag containing colored chips, which is of red, green, and yellow. So then we're going to complete the information in the table. So the first thing I'm going to do is I labeled my left side spinner and the top chips. I have purple, blue, and white. So I'm abbreviating them. It makes it a lot easier. Purple, blue, white. And then I have my colored chips. So I have red, green, and yellow. So I'm going to fill out my sample space very similar to what I did before. So I have purple and red, purple and green, purple and yellow, blue and red, blue and green, blue and yellow, and white and red, white and green, white and yellow. So this is my sample space. So now I'm going to move on to my probability. So again, I'm going to kind of write these a little bit further out because I want to be able to write down what the probability is of getting these different colors. So the first thing we should note, if I'm given a spinner with 3 colors, this means that the likelihood of me spinning any of these is equal. So I have a 1 in 3 to spin purple, a 1 in 3 to spin blue, and a 1 in 3 to spin white. Notice that this adds up to 3 out of 3, which is 1. Then I'm going to look at here. So this tells me that I have 1 chip that's red, and I have 4 total. So I have 1, 2, 3, 4 total. So 1 out of 4. I have 2 green. So I have a 2 of 4 chance of getting green. And lastly, I have yellow, 1 yellow. So I have 1 out of 4 of picking yellow. So now I'm going to do what I did before, which is multiply this information to fill in each of these areas. So I have 1/3 times 1/4, which gets me 1/12. I have 1/3 times 2/4, which gets me 2/12. And I'm going to continue this process. So 1/3 times 1/4 is 1/12. 1/3 times 1/4 is 1/12. We have 2/12, 1/12, and so on. So I'm going to fill out this table multiplying. So we end up with these results. So also notice up top here, if I add all those together, that ends up being 4/4, which is 1. It's important to note. Then I can go through and check and make sure everything adds up in here to 1. So everything inside should also add up to 1. You can always double check. That's how you catch some mistakes. So I need to answer, what is the probability of spinning purple and picking a green chip? So when we write it mathematically, it's going to look something like this, where P represents probability, and then the probability of purple and green. So I need to figure out purple and green. So purple and green is this one right here, or this one right here. So the probability of purple and green is 2/12. And I can simplify that to 1/6. Now, if I look at what is the probability of spinning blue and picking a yellow. So the probability of blue and yellow is this one right here, is 1/12.